Thank you very much. Yeah, we were already introduced. My name is Anna, and this is my colleague Christina.
Hi.
We are both software developers and IT consultants working for Cocentric, and about 1.5 years ago we started a project that has multiple microservices running in the backend, and we did it all using only JavaScript. And when we talk to friends and colleagues about that, the reaction is often something like that. They are a little bit in shock and very much in disbelief, because when you think of backend, JavaScript is not exactly the first language or within the top languages that come to mind. And today we want to show you that you can have a whole microservice infrastructure using only JavaScript that runs very, very smoothly. We want to show you 3 small examples, 3 different ways of how to build a microservice in JavaScript. So let's get right into it.
Yeah, but before we're going to go to the frameworks, we need to explain how actually the JavaScript runtime is working. And therefore, we're going to use Node.js. Node.js is actually the runtime which you mostly would use when you're going to write microservices. And now we're going to play a little bit buzzword bingo, because they're saying they're asynchronous, they're event-driven, they're a little bit non-blocking, at least they're trying to be non-blocking. We can also make blocking application with that, but mostly non-blocking is better. And yeah, they are JavaScript runtime, which is based on Google V8 engine. So we heard a lot of buzzwords, non-blocking, event-driven, but how and what does it mean? So let's start with the event loop, which is actually the basic of all JavaScript application, independent if you're going to work in the browser or if you're going to work with Node.js. For all of them, the event loop is a single thread. So all code is executed in one thread, just. But what is when we're going to try to execute something like a timer and some callbacks and stuff like this? When it's executed, what is the order of this? So in this comes the queuing of the event loop and Node.js into return. The first thing which is going to be called are timers. So if you're going to set something with set timers, that are the first callbacks which are called and executed inside of the event loop. When there are no timer left, or we reach the maximum of callbacks which we have executed, we're going to the pending callbacks. Everything that is returned from a different I/O input, or for example, something happens and we get an error message because the server didn't react, will be landed in this callback queue and will be executed afterwards. The next thing is the poll queue. It's actually the most important for us currently, because that's the one which is going to accept socket connections, input connections, which is going to process your stuff. And for example, you could call the file system and ask, hey, could you read something, or are you going to make something with the network? In this case, if you're going to work with a network connections in your callback, it will be handed over to the operating system, and the operating system is doing this stuff for you. And if it isn't this, at some points, there are also threads which are executed when you're going to read a file or process a file. But in most cases, just the operating system which is doing this stuff for you. So you're going to see we actually do not executing the real waiting on the process, on the server, in the event loop. So we are not blocking it. We are going to do it in a callback, which we hand over to the operating system. It does its stuff for us. And at some point, it will return something to us and say, hey, for example, there's something wrong in our connection. It didn't work either. So, okay, we must react on it. The next thing is the check queue. It's not so important. It has to do with something with set intermediate called, but we're not covering in this talk. At least we have the closed callback queue. This queue is actually there for a connection is closed or socket connection is closed. It will be handled in this kind of queue. And then it will be started on the stop again. So you're going to see we are going only to react on events or nothing else. If there isn't any event, we are doing nothing there. So that's the part with the event-driven. The part with the non-blocking is everything is asynchronous. You heard that I said a lot of callbacks. And yes, we are using a lot of callbacks in this context, because if we are using synchronous stuff, we will block our event loop, our single thread, and couldn't do anything anymore. That's so nice. So that's mostly the basics about the event loop and Node.js, but there's more. You got the APIs for the events, you got APIs for file systems, you got APIs for HTTP, HTTPS, and a lot of more APIs and different stuff there.
So now that we have the runtime, we can actually get into it and start our first small microservice. Let's imagine we have a small application that offers several beverages. For that, in order for the customer to actually call something, we need some sort of server. We already have Node.js, and on top of that, we put Express. Express is an open source framework that is actually designed for building web application and APIs. And it's very, very slim because most of the features are available via plugins. And so when we want to start building, the first thing that we need to do is actually create our app using Express. And of course, we want to have some sort of data. For that, in this example, we use MongoDB, and we create our client, we give it some sort of address, and then we can actually already start connecting. We didn't bother to rename the database, it's just called test, and inside of this database are all sorts of coffees. So when the user now wants to call on the coffees and get all the coffee info, what we call is this. We have our address /coffee, and then we go to the database and say, hey, give us the collection with all the coffees. And so we assemble all the coffees, and that's what we return. The last thing we need to do is actually listening. So we define a port, and we start listening. And in order to make sure that it's actually working, we are logging it on the console and say, hey, our beverage server is now listening. But there's more. I mean, in Java, you have a lot of dependency injection type, standard pattern, and if we want to have that, we need to add nest. Nest is based on Express itself and is used for building scalable, efficient, and reliable server-side applications. It's compatible with TypeScript and is partly functional, but is also compatible with object-oriented programming. And if we want to now have some sort of other beverages, for example, tea, the first thing we need to do is actually define our tea. In this case, we have a name, we have a type, and we have a steeping time. And the next thing we need to do in Nest.js is create our tea service. It's annotated with injectables so that we can actually call upon it. And this tea service is actually used for data storage and data retrieval. And that's what we see. We have our get method that calls upon the tea, and all it does is actually return all the teas that we have. In this case, we only have one type of tea that we offer. It's black tea or gray. And yeah, in order to actually receive requests, we need our tea controller, and all it does is receive the requests. And each and every application using Nest needs at least one model, the root module. And this root module encapsulates all our providers. In this case, we have the T controller and the T service. And the last thing we need to do in order to have a running small service is bootstrapping our application. And that is all the code we need for that. We have our port. And now we can receive HTTP requests and return the tea that we have.
Yeah, but that's not all. What is when we're going to try to make something like a chatbot, or you want to have real-time data? For that, we need something like socket communication, bidirectional, event-based, real-time communication, and that's possible with JavaScript. And the most commonly used library for that is socket.io. And actually, you're starting again with a server, in our case with an Express server, and you must say to the Express server, hey, you are now a socket server. And afterwards, it's going to start the socket server for you, and you can listen if an event happens. For example, hey, we connected to the socket server, we can now send and push notifications. And if we want to listen on any event, we could say socket on. In this case, we would listen on the get water event, and doing our stuff would create a new water and would say, hey, return to the emitter that we want to serve the water now. And then you have a socket communication. You must just start the server to listen on it, port again, and you're done. You could do the same with Nest.js. It's a little bit different notation. You're going to see there's an annotation on the class called WebSocket Gateway. You're going to inject the server with WebSocket server, and then you're going to subscribe to the server with get water and doing actually the same as previously. You're going to return a new water. Okay, now what? When should I consider a JavaScript backend? If you're doing fast input switches, fast switching between input and output, so if you're going to say with a API gateway, hey, I want to send this message to this service, this message to this service, this message to this service. Why? Because we have fewer context switches. We have just one thread, so no context switches between threads. It's also asynchronous, so our thread is never idle. Or it shouldn't be at least idle. It's scalable. So we have just our small application. In most cases, it's really stateless and small, so we can scale it a little bit easier, and it's never idle in this case. Socket communication, yeah. Socket communication use most often JavaScript objects. And JSON notation, JavaScript objects, is the same, so it's perfect. You mustn't manipulate something. You can create them on the run and put them in and say, hey, send that. It's typeless. It does go in the same way to the socket communication. If you have something like MongoDB or GraphQL, which are based on JSON objects, yeah, JavaScript native. So you can easily make this object, put it in, change the queries without changing a complete class in behind. And there are a lot of more things why you should consider JavaScript in the backend.
So, should you now write all your backends with JavaScript? No. Please really don't. There are a lot of cases where JavaScript simply is not the right programming language for your backend. For example, if you have a lot of file-based operations, or if you need to do heavy calculations that maybe need multiple CPUs, you will only have a lot of pain developing your backend in JavaScript. If you want to block tasks, or if you want to have a thread per user, JavaScript definitely is not capable of doing that, at least as of now. And of course, this is not a complete list. So what we want you to do is, when you have a problem that needs a new microservice or a backend, don't just throw JavaScript out the window. Evaluate the situation, consider JavaScript, and then use the best tool, because there are a lot of cases where JavaScript is really, really helpful for your backend and writing microservices. And if you have any questions, we're on Twitter. You can just reach out to us. You can come up to talk to us. And I was told that we have some time for a question or two. So now would be the right time.
Thank you very much. Of course, we have question time, because you are the last ones in the lightning talk slot. So, are there any questions for Christina and Anna?
I think there was a raised hand.
Actually, I am. Why you mentioned few tasks that are not suitable for JavaScript, but I was lacking of understanding a bit why not.
You mean this slide,
Right,
yes?
exactly this.
Yeah, actually, file-based operation is in a separated thread. It's not handled by the operating system in Node.js. So you have always something to do with threading, multi-threading, and you cannot give it to somebody else. That's the main reason why you shouldn't do so much file-based operation. Calculations, that's a big problem with JavaScript. There are really rounding mistakes, especially when you go to floating point numbers, and 0.7 plus 1.4 is not like the real number which you're expecting. It's something different in most cases. Multiple CPUs, yeah, we have just one thread which is running on one CPU, so if you're going to start with scalability, you can scale with new node service, but you can't scale inside a node service with the CPUs. Same for the blocking task, we have just one thread. When we're going to block the thread, nothing is going to work anymore. So if you have a task which takes long time, like image processing, then your complete service is blocked and it's not anymore reachable from the outside in most cases. Yeah, and single thread per user, if you have something like session scoped stuff with Spring, it's not so easy to make that with JavaScript because you have just one thread and you can't hold all session infos in this thread.
Okay, thank you.
So, thank you very much.